Hello guys, good evening and welcome to the class on Python for data science. Uh, Today we are going to discuss about what is the importance of ASCII, and we are also going to discuss about how ASCII values are important in NLP as well as in support removal, and then we are going to see how to print the sum of the ASCII values in a given word, as well as what are the string functions in this upcoming lecture. Right, without wasting time, let us proceed to code. First of all, let us know about ASCII. So generally, uh, in normal context, the machine understands in the form of ASCII values. The values which are sent to the machine are known as ASCII values. Uh, it is a code to represent the alphanumeric data, numerical data, as well as alphabetical data, as well as every digit which the user passes as an input to the computer system will be encoded with some number. It is called uh, ASCII number. It has some value. So it is represented with some value that is known as ASCII value. Okay. So what is the importance of the ASCII value? So, in every context, like if you are going to work with NLP, natural language processing, as well as when you are dealing with some stop words, to remove the stop words to predict the uh, when you are doing one hot encoding techniques, then you will be using some concept like stop word removal. So in that you have to remove some vocab using a corpus. So at that time you will be getting use of these ASCII values. So in general context, for humans, the A represents, okay, I think my screen is visible, right? Yes. So this A is equals to this A, but in the context of computers, this is not equal. So the capital A has some value, as well as the small a has different value. So both are some different terms. So this plays a crucial role in identifying the text. So what happens in one hot encoding as well as stop code removal is, let us take an example like they're given a text equals to some kind of, this is a train. Here, there are two T's. The number of T's are two, according to human knowledge. Okay, but actually, according to computer's point of view, there is a one capital T as well as one small t, which are associated with different values. So the capital T has been read with some value, and small t will be read with another value. So this plays a crucial role in identifying the words, right? So now in today's lecture, we are going to deal with this ASCII values. Okay, right? So first of all, we can print the ASCII values like if you want to know particular alphabet or particular words ASCII value, so you can directly give as just a second. If you want to print any letter, how you can print is like you can pass the character or whatever you want inside the singular double quotes, and you can simply write as print. Okay, that will be printed there, right? But now, if you want to find out the ASCII value of that particular character, here you will use a function called ORD. Okay, ORD function will be used. So if you want to print the ASCII value of A, here you have to write print ORD of, in single quotes, you have to pass that A, right? When you run this, the ASCII value of the capital A uppercase letter A starts from 65. It is the 65. It is the ASCII value of A. So as I said earlier that the capital T is different and small t is different. Right now yeah we'll find what are the ASCII values of the both the small and capital T's. Yeah, it is a T, and we'll be printing OD of capital T as well as um, it is the small t. We are finding the value of small t. So, whereas capital T resembles 84, its ASCII value is 84 and small t is 116. Here it resembles that the computer understands the alphanumeric patterns in a different style, irrespective of the both characters are same. So, it shows that it plays a major role in identifying patterns in the data. Okay, right now we have seen that how to find the ASCII value of single character. Then how can we find the ASCII values of a single word? That means let me write uh, data science. Data science is a single word, right? Uh, yes, data science is a single word. So how can you find the ASCII values, some of the ASCII values of this word? Okay, so is it possible to find the the ASCII value of this word using word? Let's check out print of word of, yeah. Uh, let's execute it and see what it will give. So it is giving a expected character error, but a string of expected a character, but a string of length 12 was found. So basically the ORD function takes only one character, okay, but it does not take in a string as an input. So you have to uh, follow some loop. That means using a for loop or while loop you have to write that, but doing a ORD function is not possible for a string. Okay, ORD function is used only for single character. Now let's find out for this word. Okay, uh, for example I am giving that txt, yeah, txt equals to I have given something word like this, some, yeah, okay, and then what I'm saying is I'm writing in a list comprehension like a equals to char of order for char in text, and right now I want to print the a. Okay, so uh, you can see that, yeah, text is not defined. Yeah, just a second. Now, even though it is resembling text, some error is there. Yes, just a second. Uh, yeah. So yeah. Uh, so what it is saying is for each and every letter, it is printing its ASCII value. Okay, in a dictionary format. So here I'm using a for loop in that for each character I am iterating and printing the ASCII value. Okay, so right now it is a single line text, but if you say that what if there are multiple lines. Okay, before going to that, let me tell you the encoding technique. Like the passwords will be sent in this kind of ASCII valued manner. So if it is the password, so 115 100 32 101, like that. If yeah, SD there is no space, so yeah, so and 32 resembles the ASCII character of space, whereas okay, so this is the somewhat given password. You please assume that this is the password. So here 115 resembles S, and 100 resembles D, and 32 is the space. For space, the ASCII value is 32. Okay, and 101 resembles E. Okay, like that. Some kind of stuff is there. Okay, please leave it. And if this has been given, how can the user can read? Okay, so what I'm doing is you can use chr function in order to convert a numerical into an that means ASCII value into a original format. Okay, and this parent print of chr of 115. Yeah, yeah, it is giving S. Okay, so chr of 115, so it is converted into S. If you want to find the ASCII value of S, you have to use the function ord, whereas if you want to find the letter or whatever is representing by the particular ASCII value, you have to use the function chr. Okay, right, sorted. So in this way, they will iterate a loop, and they will find out the password. So I have given something SDEVL something is given. So what I'll do is this is basically I have reversed the text using uh, just a second. I'll show you text uh, text of using this list minus one. When you're doing this, you will get the original pattern of the text whichever I have passed. So I love data science. So this is the original format, and I have given in the reversed format. Okay, if you are doing the reverse again, uh, just a second, yeah, then it will be equal to the text SDEVOLI. So I am reversing the pattern. So sometimes whenever you send the details like any confidential details, you can reverse them, and in the reversed order you can send them, and they can re-reverse the string to get the original string. This is the one of the encoding techniques. Okay, uh, so yeah, proceeding forward. So you can find the what is the single character value ASCII value, as well as a whole ASCII values, whole word, as well as a whole words list ASCII values. And now you are going to find out what is the sum of the ASCII values in a single string, whichever is given to you. So right now, I am writing a program like I am defining two names here. I am defining two names here, name one and name two, and then I am taking two counter variables, uh, C1, and initializing their value to 0, and C2, and again initializing their value to 0, as well as then I'm taking the for loop. And then this is the basic syntax, and this is the same thing whichever has been taught in previous lectures. I'm taking C H char 1 comma char 2 in. I'm using the zip function, uh, whichever is gives the name 1 comma name 2. Right now the logic is implementing like what we have to do here is we have to print the character and the ASCII value of the character, right? So right now I'm going to print char1 comma ORD. ORD is a function used to print the ASCII value of the character. So char1, same as it is I'm writing for character 2. Char2 comma T of. Okay, sorted. All right. After now, I have to increment the count value. Count c1 plus equals to whatever I have to do is I have to increment the count. That means like I want to find out the sum of the ASCII values of that particular word, right? So I have to add the previous ASCII value to my sum. This is the count. Count is initially 0. First, if I take A, this is the 65 should be added to C1, and then the value is updated. The value of the C1 is updated to 65 as A's ASCII value is 65, right? So let me do that. C1 plus equals to, how can we do that? So we have to find the ORD of char. This is the representation of the ASCII value, as well as C2 plus equals to ORD of, yeah, char1 and char2, right? Then we can print those values, right? Print C1 comma C2. Okay, yeah. So I have not given any kind of names over here, so it is printing 0 comma 0. So if I'm giving some input like Gdsc Python, and now I'm running. So for each and every value G, P, D. So for each and every unique value, it is printing those ASCII values, and it is printing their sum. 417 is for GDSC and 453 is for Python, right? So this is the code. If you want to find out what is the sum of the ASCII values of your name, here you can use your name to like some kind of you can play with the names, right? So I'm not going to encourage that. So yeah, sorted, right? Yeah, we can now uh, uh, yes. So if you want to find out what are the ASCII values for A to Z, you can write like uh, for I in range of, it is the simplest form of using different kinds of functions like ORD function, CHR function, range function, loops, for loops, while loops. This is the simplest ways to represent the ASCII formats. By using all these functions which are available in Python, we are going to extract the ASCII values as we want the output in our likely format, right? And then so what I'm doing here is for I in range of 65 comma 91. So what is the, yeah, here what is the value of capital A? I want letters from A to Z as well as their ASCII values. So I can find out. So let me show you. Print. Now I'll write ORD of capital A. So what is here? It is given 65. So if it is my starting value, right? So what is the value of capital Z? It gives this, yeah, it gives me 90. So how far should I iterate in this loop? The range is from 65 to 91. So I have printed that ASCII value as well as the character. Okay, sorted. This is the ASCII values as well as the characters from capital A to Z. So as well as you can print, you can take small a, it is starting from 97, as well as the small z, it will be at 122. Okay, so you can define the range here 97 to 122, and you can get this lowercase letters, right? And now we are moving to, yeah, right now, if you are using like here it is printed a line wise order. I want to convert them to a list, like list dot join. I'm using this, and then uh, chr of I, yeah, this is the list comprehension for I in range of 65 comma 91. So if I run this, so it will give you the values of A to Z. Okay, so here you can play with those, like defining the step values. So it's all how you use the functions, like what are the parameters you pass, and in what ways you can use, like that. Okay, so now, let me tell you some pattern kind of. For now, we have seen like how to print single ASCII value, single word as well as a set of words. How to find the sum of those ASCII values in two different words, and how to find their difference, as well as set of passwords, how they can be cracked using ASCII values. All this set of things has been observed till now. Now we are going to observe uh, like a pattern, like I wish is a pattern. Then the next pattern would be AAB, AAC, like up to ZZZ. Okay, so what I am going to do here is, like, first of all, I'm taking a string. First, I'm iterating the last word through last word, and I'm changing the last single character A, B, C, D. After A, A, Z, it becomes A, B, A, like that. In the final output, I have in the final string, I want Z, Z, Z. Okay, so let me simplify. Instead of taking three letters, we can take two, A, and A, B, AC, and lastly I want ZZ. So because running the loop for multiple number of times, it will produce so mm, just a second. So for single character we have to iterate 26 times, 26 cube, that means 26 into 26 into 26. uh, so that many times it has to run the loop 17,576 times it has to iterate the loop. So uh, what we can do is we can just take two letters, okay, two characters, and then we can write the logic. So whatever pattern we have to find out is A B A C, like that up to ZZ. We have to find out the pattern. So I am writing code to find the pattern. Just it is simple for ASC1, that means ASCII 1 in range of 65 comma, as I am defining the capital letters only here. So 91, and then again in the for loop you have to iterate the same thing. So for ASC2 in range of 65 comma 91. So whatever you have to print is print chr, that means character of ASC1 comma CHR of ASC2, right? So here it prints like it is running. Yeah, I'll show you that. Just a second. So here it is showing AA, AB, AC up to just a second, BA, BB, BC. This is the sequence repeats. Like for every character, for A there are 26 times it is repeating. From for A it is giving A to Z, and for B it is giving A to Z. Like that, for Z it is giving A to Z. In the final outcome, we acquired ZZ as the string. So uh, why I explained here is if you are setting some password, like if you are setting a 5-digit password and it contains some capital letters as well as small letters. So if your password is something like 5 years, so 26 power 5, okay, so you have to iterate these many times for every single character in the password. So here it is taking a lot amount of time in guessing the password. So it is highly advisable that you should be taking passwords of length greater than 8 characters. So it is not easier to crack those passwords in a single attempt. So this is the higher use of ASCII characters in the context of passwords also, right? So this is a much about ASCII. Right now we are going to shift towards some sort of string functions like txt equals to I love ds. Something I love data science has been given, and I am executing that. Txt dot, yeah, so dot upper. So the uppercase converts all the text into the uppercase, right? So and then this is one of the function used to convert the lowercase to uppercase. And if it is upper, I'm assigning it to txt equals to txt, and then I'm running that. And now what I'm doing is txt dot lower. This lowers all the uppercase characters to lowercase. It converts the entire string into the lowercase. And these are the some of the string functions which are used in case of stop word removal. That means, as I said earlier, this T is different and this T is different in the context of computer language, as there are different ASCII values to it. So first of all, whatever string you're taking into consideration, you have to convert the string either into the uppercase or into the lowercase. So it is highly recommended there, which you will be learning in the program of TensorFlow. And then, yeah, you have some functions like replace, find, and count. Let us see that. Txt dot replace. Here you have to pass two parameters like uh, I'm passing love, comma, hate. So whatever it does is it replaces love with hate. And why it is giving I love ds, it is converting, just a second, txt equals to, right. What it does is it converts wherever the love is present, wherever the first word is present, it changes the first word into the second word, right. And then mm, done. And there are other functions like find, count, txt dot find of I. So where it is found, it returns one. So okay. Oh, not found. Oh, so here you can see that if the particular character is found, it returns the index of the character where it has found. If it is not found, then it will return you minus one, right? Okay. So here I'm giving I yes at the ninth place. Yes, as is present at the ninth index, right? And then we has count txt dot count of what is the common thing, there is nothing common, so I'm just giving you l. So count of l resembles how many l's are there in the given string. So there is only single l, so it returns you one. So these are the some common functions which are used in the context of strings. So this is the basic knowledge which you have to acquire when you are moving to any machine learning or natural language processing kind of stuffs. So uh, this class aims you to share knowledge about ASCII values as well as some stop word removal techniques which will be given to you in future workshops like TensorFlow. So the main aim of this class is to create awareness about ASCII as well as covering some important stuff like what is the ORD function, CHR function, which has not discussed till now. And we have seen different values like taking two names and calculating their sums, and we have seen how to convert passwords like reversing the passwords, right? Okay, so this is the stuff, and if you are having any doubts you can ask. In the upcoming session, we will be teaching the problems related to the mang level problems, like some problems which are asked in the uh, mang companies like Google, Microsoft, Amazon, right? So, and also there is a one more topic that is important in the context of passwords, like anything regular expressions, which is the important concept which we are using in our daily life. It will also be taught using some project like password strength checker, how to check the strength of the password using the regular expressions, right? Thank you guys. That's all for today's class, and thank you for joining.